Okay, so now that we see this massively incredible particle engine that we're going to be creating, we need to go ahead and start with getting our controls in place.
That's right.
So the first thing we're going to do is we're going to create our control class, which is really just going to be an abstract class that we can pull off of and build onto for each of the various controls we're going to need.
Right, because every control that you create, whether it be a button, a list box, anything, has some default things that everyone has. A position, an X and Y, a width and a height, and so on and so forth. And creating an abstract class will allow us to have something to build off when we create our button, so we don't have to repeat code
every time.
Yeah. So we're going to create two files. We're going to create our control.h and control.cpp. So let's go ahead and create these guys. So control.h.
And while Joel is doing that, let me just explain. We are using our little SDL demo that we've been toying with this entire time so that you guys can at least see the controls functioning starting in the next video when we implement them.
Right. We'll basically put in the base code necessary to get controls drawn out, and then every time we create a new one, like a button or whatever, it will automatically start working. So we don't have to write in all that extra code.
That's right. Well, I'm just letting everybody know how our application is just going to slowly morph here.
Yep, exactly. So let's go into our control.h and do the mandatory if not defined control underscore h. Define control.
Say it as if it's almost like a sentence.
It is.
The mandatory if not defined. Here it is. Yay.
So let's define our class control.
Of course, now let's...
Semicolon. Thank you.
Yeah. But even before then, let's go ahead and include our GL engine.
Yep.
Because that's the beauty of having everything encapsulated within it.
It is. So now inside of control, we can start drawing text or whatever. All right. Now, there's a few things. Creating custom controls is kind of a chore. There are a lot of things you need to handle manually. Well, everything. You need to handle everything manually.
Hence, custom control.
Exactly. So one thing we're going to do is create a structure that allows us to see the current state of what we need to know. And in this case, we need to know the current state of the mouse because we need to know where the mouse is. Is it over us? Is the left button pushed in? Is the right button pushed in? Et cetera, et cetera. So we're going to create a struct
that's going to hold this information for us.
And we're going to update that inside of our SDL demo main loop. So we'll call it struct mouse state. And we'll store our left button down, whether or not this is down. If it's 0, it's not down. If it's 1, it is down. And our right button down.
Our middle button down.
People are going to think I can't spell once they see this. He's the illiterate programmer. Then we have our int x and our int y. And let's go ahead and create a constructor, if you will, for our struct, because we are allowed to do that. Every time you create a new mouse state, it's going to call this mouse state area.
Right.
And then we'll just initialize everything to 0. So our right button down equals 0, and our middle button down equals 0. And finally, we'll initialize x and y to 0 as well. This is just so that at the very beginning we have a valid state. Otherwise, that's not good.
Okay.
So now, what are the kind of things we need inside of our control? First off, what kind of private members do we need? Or actually, protected. Because remember, we do want our children, be a button, a list box, whatever, to be able to access these as well. So if we made these private, then they couldn't access them. So we'll create these as protected so even our children can access them. So under protected, one thing we want to keep track of is whether or not the mouse is currently inside of the control.
Right.
And we'll just store this as bool inside. We also want to store where our control is located on the screen. So we're going to have a position X and a position Y. Also width and height.
Right.
So we have the width of our control and the height of our control. So these are the main things that we need. Another thing, much like when we did our texture, I believe, yes, in our texture, we stored a list of every control that we create, texture that we create. We're going to do the same thing here and store a list of every control that is created. So a static list that has control pointers. And we'll just call this control. So in our constructor, we'll actually add this into this.
Which now we can just go ahead real quick before we move on. Let's go ahead and include lists now that we're going to.
Yeah, I knew you were going to say that. Oh yeah. So we're gonna.
Otherwise, we'll forget.
Yeah, we will. Include lists, and then we get a whole bunch of errors, and we freak out and all that stuff. So using std list.
Excellent.
And let me go back into here, and let's define another public section. I just like to separate again variables and functions.
Oh, sure. So we go ahead and do our constructor.
Our constructor, and remember, all of our base class, all of our subclasses, button, for example, we'll call this constructor. So int position and x, int.
Yeah, the key things basically. Where at, how wide, how tall.
And, of course, we have our destructor as well. However, our destructor needs to be virtual. Otherwise, they won't get called in the proper order. So this virtual is very, very important. Do not forget it. And then we're going to create some virtual functions that all our children must update. So the first thing is update control. And you'll notice I'm returning a bool here. Basically, update control checks if there's any events that need to be handled. For instance, if I click down on a button, right? Mm-hmm. And when I'm inside the button and I press the left mouse button, I want it to send an event back. And we do that by sending back true. That means something just happened with our control and is now processing something. And we pass to our update control
just the address of the state, yeah.
Yeah, so we pass it the state, yeah. And we'll also need a draw control, which simply does the OpenGL commands that draws our control onto the screen. 2D, remember. And this is going to be a void. And we're setting this equal to 0. Now, just because of this line, we instantly know that control is now an abstract class. We cannot create instances of control simply because we have an equals 0 here, which means a function is completely not defined. So you can't create a control that has undefined functions. It's just not possible. And every single one of our subclasses are going to overload that function, as well as a getType function. And in this one, each control is going to return its type. So it will return, like a button will return quotation marks button, so that we know what kind of control was just created. And we'll set that to 0 as well. Now we'll create a few accessory functions, exactly. Set position, int x and int y if we need to change the position. We'll also set the size, int width, and int height. And some other accessory functions to get the width and height. So get width and get height. And I think that's everything. Clean that up a bit. Oh, we do use a string here. So before we forget that, let me come up here. I actually beat you to it this time.
Yeah, I was going to say, don't worry. It was going to be in there.
Yeah. Using std string.
You were just on a tight flow there, and I didn't want to mess you up.
So if I talk too much, then you can't say anything.
Because I can't get a word in edgewise.
Yeah, I know. So let me copy all of these functions, because, well, except for the virtual ones here that we have that are equal to 0, we'll just remove them. First thing, include.
Haha.
Haha. We said it at the same time.
Yeah, I know.
Doesn't count. Include control.h. So
scope them in.
Scope them in. Scoping. These guys, let me just delete them out. And no more virtual. All right, so here are our functions.
Get rid of all of our terminators and block them in.
So copy that. Too many spaces. Let me just finally clean this up for spaces, and that's it. So inside of our control, very, very simple. We have that list of control pointers. Simply push ourselves onto that list.
That's right. Set our position X.
Set our position X and Y to what was passed into us.
And of course, set the width and the height.
Yeah. Let me change this because this is confusing with our own names. So W and H, just to make it easier for us. And height equals H.
And in our destructor, let's just remove ourselves off that list.
Exactly. So controls.remove this, and that's that. So then our update control, what does this do? Well, I want to update control. You could define this update control as equal to 0 as well, so that every single one has to overload it. But what I want to do inside of update control is update this inside variable, because this is something that every single control needs to know. Am I currently inside or not, So if we come back into here, let's go ahead and write the code to do this. So we get the X and Y. So in state, we have our X and Y. This is just to make it a little bit easier, so we don't have to type as much code. And then we simply check whether or not the current mouse position is inside this control. And this is really easy to do. The X position has to be greater than or equal to position X. And it has to be less than or equal to the position X plus the width of the control.
Which only makes sense.
And same for the height, and Y is greater than or equal to position Y, and Y is less than or equal to position Y plus height. So if it gets in here...
if that's the case, then inside needs to be set to true.
Equals true. Otherwise, at the very beginning, we can assume that it equals false. and then inside here we'll actually call this.
That's right.
And this is called every single time. On every single loop, we're updating the control. So just keep that in mind. And also, when we create our button is going to do something like so, control, call, update control, and it's going to pass state. Because we want every single control to call the base functions update.
Right. Then we just return false.
Yeah.
Because we're just setting that.
Yeah, we're just setting it. We're not actually controlling anything.
Right.
So inside of here, very simple. Position X equals
this
X.
stuff is easy.
Position Y equals Y.
And the size.
Width equals W. Height equals H. Excuse me. Oh, yeah.
Now with accessory functions, that's all right.
W and H.
Yep.
All is good.
Now for our gets, we'll just simply return
width and height.
Width and height.
Not in the same function, but yeah. Let's return width and height. And I think that's everything we need. One other function I'm going to create just as a utility function. It's kind of a hack, if you will, but something that allows us to add controls easily. So if we come back over into our control.h, we'll create a simple utility outside of our class, just an extra thing.
Okay.
And we're going to return a control pointer, and we're going to call it add control. And we're going to pass it a control pointer.
Yeah.
And so let's create this in our control.cpp. Basically, it's going to allow us to create controls without worrying about positioning them. So what I'm going to do is create two static variables, static int last x, and I'll initialize that to 5, static, and you'll see what this all means in one
While
second.
you're typing that, I'll just go ahead and say, obviously, in this case, I mean, when you design your own graphic applications, your add controls is going to be way different.
Right. Basically,
we're just making of controls.
Exactly. We're going to arrange them vertically.
That's right.
If you're used to WX widgets, you have the ability to arrange controls horizontally, vertically, add them in together. The whole arranging system is complex.
We could take add control itself and just really spice this guy up a bit to take in locations and things like that if we wanted to.
Yep. But in this case, we're just making something really simple for a demonstration.
Starting out at 5.5 and just pushing our way down.
Yep. So we'll
based off the height of each control.
Yep. So we'll do a set position for the current control, and we'll add last y. Well, plus equal. Thank you. Control.getHeight.
And then we'll add, like, say 5 to it, just as a spacer.
Yep.
Yeah.
Beat me to it. Then we'll return the control again. And basically how we're going to call this, something like so. Let's say we create a button, right? And I'll call this button OK. And this is going to be equal to add control, and then I'll pass it a new button, and let's say just X and Y. So the width and the height of the button.
Right.
So 230 or something like that. And then at this point, it adds the control and sets the position and returns it so we still can store it in our own button. Okay, so that's basically how this function works. And again, as Buzz said, you can go ahead and make this really complex if you wanted to.
Joel said this is kind of like a hack because we know we just want a vertical list of buttons.
Yeah.
And so we're just kind of predefining that this is how it's going to happen. With each new control we add, it's just vertical, starting at the top. One, boom, boom, boom,
exactly.
And that's it.
So let me just go ahead and delete this. Let me make sure there's nothing else I wanted to add before moving on. One thing that you may want to do, some people are really stickler about this. You can call this as set position and then pass it position X and position Y. This is completely on preference because that does take a little bit extra time. But I just thought I'd throw that out.
Sure.
And you can do the same with width and height. So now that we have this control, let's go ahead and go to our SDL demo. First thing is, we need to include it. So let's include our control.h. Of course, we can't create instances of this, but we just want to make sure it compiles properly. Awesome. I totally made some mistakes. Oh, wow. Let me put that there. That might make things a little bit easier. All right. Illegal left-hand side. Let me kind of make this a function call instead of a variable, because there is no variable called getHeight. And, okay. Finally, I totally forgot to, remember we have a static, if I go back into the header here, we have a static list controls. We need to define that inside of our control.cpp. So all I need to do is come in here and define this, and you're done.
Cool.
And that should clean up everything.
And it does.
And it does. Sweet. So at this point, what we're going to do is go back into our SDL demo and kind of add in the necessary code so that we can start handling controls.
We're just setting up the infrastructure. I mean, you're not going to see controls pop up.
You're not going to see controls.
Because we haven't really defined controls. Just the abstract class. That's all we've done. Yeah, just the base.
And in fact, let me just point something out real quick. If we do a control, just to kind of drive this home, I'm probably beating the horse to death, but 2 and 2. If I try to do this, notice what it's going to say. Cannot instantiate abstract class. Remember, that's because we have the equals 0.
That's right.
Just thought I'd point that out in case someone ran into that and error is like, whoa, what does that mean? So anyways, what do we do to get this all working? Well, we need to have some place to store our current mouse state. So we'll do a mouse state and create a state. And we'll update this in our loop. And another variable we want to create is the current controlled function, a controlled control, if you will.
Right.
And we'll just set that to null. Basically, this is going to hold a pointer to the control that is currently being modified, being manipulated.
Right.
If we had our slider and we're dragging it along, control is going to hold the pointer to that slider.
Right.
So if we go all the way down, there's a few things we're going to create. And just to kind of simplify things, we're going to go into draw scene and go down to draw scene right here. After we've set the orthographic view, I'm going to do a GL matrix mode and then load the identity for that so that we move everything back to where they originally were. And you can do this inside of set ortho if you wanted to, but in this case I decided not to, simply to make it more clean. So once we've loaded that, I want to call a function called draw controls. And this function is going to be what's going to loop through every single control that we've created and update them and draw them. So if we come up to our before our draw scene.
Can I see the code you just added?
Yeah, sure. I added a geomatrix mode model view, and then I just loaded the identity.
I was just going to say, do we want to add that after display FPS?
We can if we want to. I mean, basically, this means that our controls are going to be overlaid on top. And that's true. Our controls kind of have priority, if you will. So we're going to display our FPS and then draw our controls.
Okay, cool.
Thank you.
No problem.
I miss things every now and then. Can't help it. So here we have
I'm still amazed you're able to type all this out with almost no errors.
Yeah, it's still kind of funny.
It's still thankful that you don't make me type. 15,000 errors.
Well, at least it makes it not boring for me because I get to do stuff. So in our draw controls, what we need to do is loop through every control that's been created. Now, we could maintain a list of all the controls that we've created manually, but that is why we've maintained that static list of controls that we have. So we can simply loop through this. So let's create an iterator, as we've done many times now. We'll just call this IT, and we'll equate this to control, : controls. And we made that public so we can't access it. And we'll just say begin, and then IT does not equal controls.end, IT++. And now we can loop through every single control. So let's first get the control that we're currently looking at. So control equals IT. And then what do we need to do? We need to draw the control first off. So let's do a draw control. And then we need to update the control. So we can do an if control update control. Remember, if it returns true, that means it needs to be updated. Well, it has or is in control. And we pass its state.
And then you need to set controlled to that control.
Right, because remember, we set that up there.
Upstairs, that's right.
Wow.
And it's just going to hold whatever control is being currently
manipulated. And then at this point, this means some event has happened, maybe, whether it be a sliding event or whatever. So we'll basically handle the events here.
Right.
Any events that you need to handle. Otherwise, that means we don't need to handle something. Or at this point, this would mean control has been updated, but the control has been updated, but no messages to handle, right?
Right.
And then we can add in another else if condition that says if the current control equals the controlled. What this means is this one had control, and now it no longer has control. Because if we got to this else, that means that the update control returned false, which means we're not handling anything anymore.
Which means we need to take controlled and set it back to null.
Right, and say, okay, this control no longer has control, set it to null.
Right.
So that basically gives control back to us, or whichever other control. And another thing we need to do is right after the draw control, and this will make the whole control thing make a little bit more sense. Basically, we'll say if the controlled does not equal null, so that means a current control is being controlled, and controlled does not equal the current control, we're going to continue. So basically, if a current, we went through this loop once, this got called. So let's say our slider is being controlled and we have 10 sliders, okay? So our one slider is getting controlled. We don't want any of the other controls to take away our control because we want to maintain control. So if the control does not equal null and the control does not, the control is saved, and we're looking at another control, go ahead and continue. We'll draw him, but don't actually handle messages for him.
Right.
So that allows us to maintain control to one specific control, and that's very, very important. So at this point, I'm trying to think if there's anything else that we need. In our main loop. So we've got the draw controls, but we need to actually update our state, right? Because if I just compile this real quick, make sure everything's running fine. We don't have any buttons, but at least it compiles okay. And at this point, we need to update our event table, if you will. That mouse state that we created, we need to update that. So right before our draw scene, let's start updating that. And we have a really cool, convenient function called SDL get mouse state.
How nice of them.
And it has two parameters. A pointer to the X component and Y component, which will basically set whatever you pass to the current location of the mouse.
Yeah, so we can just say the address of state X and state Y.
State X and the address of state.y.
Beautiful.
Yeah, that's right. And then we want to update the left mouse button down, right mouse button down, middle mouse button down, etc. So we can do state.left button down equals, and this same function, get mouse state, returns to us a mask, if you will, of all the current buttons that are held down. So if we just pass null and null, because we've already got the X and Y, we don't need them again, and we can AND this, mask off only the bit that we're concerned about. So this returns some sort of integer that holds a series of bits saying whether or not, left button down, right button down, etc. So we AND that with
SDL button 1.
And this is a macro that specifies which bit we want to worry about. And when we pass it 1, that means we're worried about the left mouse button. Does that make sense?
Absolutely.
So let me copy and paste that 3 times.
We're just dealing with 2 bits here.
Yep. Or 1 bit or whatever.
Well, 1, 2, and 3.
Yeah.
And 2 bits to represent.
Oh, right. I see what you mean. Yeah. So I think that's
0,
it.
1, 1, 0,
wait,
and
this
1,
one
1.
is right.
Yeah.
Right. Thank you.
It's all good.
So we have our left button is 1, middle button is 2, and our right button is 3.
Excellent.
So I think with that's pretty much everything we need. There's one final thing we can do, and that is when we create our new controls, you would have to at some point delete all of those controls, right? So we could either, if we use our add control mechanism, we could store that pointer and delete them all manually. But what if you have 20 controls? That means you'd have to have 20 individual delete commands. But let's go ahead and simplify this a little bit. Copy this bit of code, go all the way down to our uninitialized here, and right before it, we can simply delete that pointer.
Right.
So we loop through every control and delete it so that everything's out of memory.
Right.
And let's just run this to make sure everything. Of course, you won't see anything different at this point. But if it runs, that means we have the infrastructure necessary to start handling controls.
Which is awesome.
Yeah. So I think
now in the next video, we'll go ahead and put together a button.
Yep.
And show a button on the screen. Woo!
Right, which should be cool because we can just focus on creating the button code, and then all the infrastructure is here. We say create new button, and we're done.
That's it. All right, so with that is going to wrap up this video. Thanks a lot.